I'm Connor from Fishtown Analytics. I'm here to talk to you about your favorite, sexy new wave data technology, SQL. So I live in Philadelphia. I'm the co-founder of a analytics consultancy called Fishtown Analytics. So we help venture-funded and growth-stage companies build out their analytics discipline. In addition to that, we build an open-source data modeling tool called PBT, which we're going to touch on in this talk. And I come to data engineering through the same route as I think a lot of us, as formerly a senior application developer, DevOps lead, engineering manager, those sorts of things at data companies. And then one day somebody decided that I was a data engineer. So, okay, so why talk about SQL? I think SQL is very old and it's everywhere, and so a lot of people know a lot about SQL. But I think one sort of novel thing about SQL right now is that with the advent of technologies like BigQuery and Snowflake and Redshift, we've really democratized cloud data warehouses to the point where a lot of small companies are able to use these tools that formerly were only available to very large companies. So we can give serious compute power to people that only know SQL or maybe sort of less technical than a lot of data engineers. And I think the other thing that we found that makes SQL relevant is SQL is just the lingua franca of data. There's a lot of people that know enough SQL to be dangerous or can pick up enough that they can do some damage with it without necessarily needing to have an engineering background. So it's a good tool to use as our common language with the less technical folks, business users, and so on at our companies. But SQL has some limitations. It's static. It is declarative. There's not so much that we can do with it. So this talk is about how we can extend that, make it more powerful, and get a little bit into DBT. So I think the obvious sort of example or parallel that we can draw here is to something called HTML. For those of you that have an application development background have been doing this for a while, you've seen things like this. So let's say we wanted to create a user's page where we had a list of links and each link linked to the profile page for that user. There was a time where there were two ways to do that. One was if you wanted to add another user, you would type some HTML code and FTP that up to a server, check it into Git, and deploy it, and you'd end up with a page with another link on it. Or you could write this PHP stuff where you kind of print out HTML and generate it as you work your way through code. But after a little while, people figured out that this wasn't a great way to do this. Number one, there's a whole group of people who know HTML who can't understand and probably don't want to understand the stuff on the bottom there. And we really want that group of people to be able to contribute to this this part of our stack. So people came up with this idea of HTML templates. So the idea is you have mostly HTML, but inside the HTML you have some other stuff that adds some dynamism to the code that you're writing. So this way we can, instead of either typing more or writing a for loop, we can sort of smoothly generate the page that we were trying to generate. So the parallel to SQL is easier. SQL, like HTML, is text-based. It's declarative. So we have a similar idea here. You can just write a query. That works well in a lot of cases. Or you can write this messy stuff at the bottom that spits out some SQL as you set flags and those sorts of things. I hope that no one is doing this and that you're using R to generate this, or you're using some library to generate this type of code. But this is sort of how this stuff works under the hood. And so the basic idea of this talk is why are we doing this thing? Let's use templates with our SQL. So this is an example of a Jinja template that can conditionally add a where clause to a SQL statement and can kind of modularly build up a SQL statement using these things called CTEs. So for those of you who aren't familiar with CTEs, this with base as select star from orders table. That's called a common table expression. And that's a way that we define, we like name this query as base, so we can select from there. Okay, so why is this a good idea? I think, like with HTML, we can just write better and nicer SQL by doing this. We can do a lot of things, like we can open source code. We can, like share this code as if it was SQL with other people at organizations and outside of organizations. But I think really, like the power here is that we can do some things to make SQL more capable. So we can develop actually like advanced functionality within our SQL queries beyond just like writing plain SQL. And with that comes this idea that like we can actually check this code in to a Git repository and make our analysts who are writing SQL code work like software developers. So we'll talk a little bit about that. But really this helps this type of like transformation code or advanced analytics code fit into the way that the rest of your data engineering team is working at your organization. So the rest of this talk is really just like a fast and furious rundown of some use cases that we developed here. A lot of these, all the code that I'm going to show is like valid DBT code that you can use if you use DBT, and we'll talk a little bit more about what that means as we go. But the idea here is that you shouldn't have to use DBT to use some of these ideas. So you could, if you were so inclined, you could install Jinja and start writing your own template engine for SQL. Oh boy, that's tough to read. Okay, so one of the basic things that you often want to do in SQL, but it's really hard to do, is a pivot. So if you look on the right here at the top, we have an input table that has a size and a color. And what you often want to do is just get like a count across those two dimensions. So we want to say like, how many items are there in this database that are red and small? How many are there that are blue and medium? And you want to build a table of all those values. So it turns out that like SQL isn't that good at doing this kind of thing, but it's a use case that analysts want to achieve like pretty often. So the way that you would normally write this is you would write like case when color equals blue, then 1 else 0 end, case when color equals red, then 1 else 0 end. And like our HTML example, you would sort of write these statements one by one. So what we've done here is we've written a macro in Jinja that just does that. So you give it the column that you want to pivot over, you give it the values that you want to use for the pivot, and it will just generate all those case statements for you. And it sort of dynamically inspects the database to get the values out. So one problem with writing it yourself is when we add a color green to this table, then we don't have a green column. Somebody has to go and update this. So we now have this ability, when we run this code again, we'll automatically inspect the database and include green as a new column in this table. So another kind of use case is materialized views, or materializations as we call them. So there's this idea that like you might want to take a select statement that you run frequently and then just run like create view as, and then pass that select statement in. So you might want to create a view, you might want to create a table, you might want to create an external table, you might want to create some different constructs in your SQL database depending on what you're doing. But all of them sort of take a select statement as the input and then spit out like some kind of construct in the database. So this is sort of an example of how you might do that. So given this like with input as selecting, which is just defining the select statement, we can then pass that select statement into all these different materializations and build things in different ways by passing a configuration parameter to this code. So if we wanted to go and write a bunch of if statements to say if config equals view, then build that and so on, do that. So in DBT, we have like a bunch of materializations that leverage this concept. We have using tables, which I just showed, external tables. But we can also do things like build tables incrementally. So when you have a source table that gets new rows, we can figure out what the new rows are in that table versus the table that we've already built and just bring in the diff. And we can do things like date partition tables in BigQuery and add sort and distribution keys and so on. So there's really a lot of power when you can dynamically adjust the SQL that you're writing based on the database. So another use case here is DAGs, and so this is sort of the like secret sauce of PBT, I guess. So this is a pretty typical like analytical query. If you all can read that, that we see. So the idea here is this is Snowplow data, which is an event tracking system, and we have this Snowplow sessions table, this raw Snowplow sessions table, that is all the sessions as given to us by the Snowplow system. And we also have this Snowplow ID map thing, which is like a user ID mapping. So this is just a query that takes those two tables and joins them together and gets like the real user ID for this user. So two sessions, as given to us by Snowplow, have different user IDs, but we know that they're actually the same user. We can combine those two session, we can give those sessions the right user ID by running transformation code that looks like this. And this is like not the simplest SQL, but it's sort of simple to understand. Like there are two inputs to this, and then there's one output that just has a different user ID, and it has a new session index field that tells you what number of sessions is this for this user. But it kind of gets complicated when you start to think about like the number of transformations that you might have at your company. So if you have 30 things, SQL scripts that look just like this, it's pretty hard to track how those pieces fit together. It's hard to say like, hey, just run all 30 of these in order and make sure that everything's going to be built in the right order without manually managing all the edges, right? So you need to tell your system that this table depends on raw Snowplow sessions and stuff. So in DBT, we built this concept of a ref. So a ref is a function that you call in this templating library, and it does two things. So first, it renders out to like schema.table. So it's just going to reference that table. And in the background, it basically adds some metadata that represents an edge in the graph here. So when you go to actually run this Snowplow sessions script and its predecessors, like its dependencies, DBT can work this out and run both of them in the correct order. So like as you start to build these up, what you end up with is a DAG where each node in this DAG is a table or a view or something that's built in your warehouse that is like an artifact that's actually there. And you can sort of pick and choose different sections like subgraphs within this DAG that you want to run, right? So if you want to rebuild just this very top right node here, we can sort of easily traverse the right stack and figure out like, okay, we need to build this node in all its inputs, or we need to build, we changed this node, so we need to build all its outputs, etc. So I think the thing that really falls out of this is like this ability to build curated data sets. I think this is something that has been talked about a little bit at the conference already. So we can break these things down by like into groups of raw data. These intermediate transforms, which look like that Snowplow sessions thing that we just looked at, but maybe that's not something you actually want your analysts or end users to query directly. But you have this ability to create, maybe in a different schema, a set of production transforms that these people can look at directly. So it really gives you a lot of power to control like what things you want to give to your end users, what things you don't, and what things are raw data. So this is one example of a DAG that we have built. This is the actual DAG for the Snowplow example that I gave. This is the complete DAG. So you can see we start from this like Snowplow base events thing. We have a Snowplow base web page context, which provides more context for those events. And then we sort of go through all these elements in the DAG and end up with the three things that you want out of your event data: page views, sessions, and users. And then all of our analytics are powered by those three things. So if you get the slides after the talk, I have a link here to the code for this, and we can maybe walk through that. Yeah, so just to give an example of the curated data set version of this, this is a DAG created by Parsley. So they're a company that's using PBT. The way that they use it is they give their users, or their customers, a raw event feed. So it's very difficult to read, but this leftmost thing here, this is called Parsley raw data. And that's just a table with like all of the raw events that are going through Parsley's system. So they ship those to like their customers' Redshift clusters. And then all of these transforms down here are defined by their DBT project. So they'll ship you a DBT project that you can run and generate all these like use case specific tables downstream. So again, it's very difficult to read, but a lot of these have to do with like views on video content, views on post content, page views, all these sorts of things that you would want to analyze from your users in specific rather than just getting this like, huge product. Okay, so in short, use SQL, it's great. Use templates, they're awesome. If you have any questions after, you can feel free to stop the outside. But I think we have some time for
we have some time
questions.
for about 5 minutes of questions.
Yeah. Anybody have questions?
I'll kick off the questions. You mentioned application development being part of your earlier career.
Yeah.
How do you see this in relation to things like ORMs and maybe more generally just using full programming languages alongside this to do more advanced transformations or for like full-on software developers?
Yeah, so like one of the things that we didn't really get into with this is the outside transformations part, which are like definitely very important. So in relation to an ORM, I think with an ORM, you're sort of defining this like meta language over SQL. So you're basically saying like, I don't really want to write SQL, I want to do something else. And the idea here is very much like SQL is the tool, so let's use that as much as we can and try to enhance it in ways that make people more productive. Yeah, on the outside transformations piece, I think one of the ways that we're seeing people use their warehouses most effectively is to run these types of SQL transformations and then run other transformation pipelines where they load data out of the warehouse, run transformation pipelines on it, and then load it back in. And this is all for analytical purposes right now, real-time stuff. But I think that again, like getting everything into the warehouse is a really important step to like democratize all this data and give your analysts access to everything that they want access to. Yeah.
To elaborate on the what you're talking about how you get arbitrary compute to kind of break out of DBT in order to do that, right?
Yeah.
I guess are people typically just using a workflow engine like Airflow or something to orchestrate this? And then, but at that point, I guess if they do that, then from Airflow's perspective, DBT is like one huge black box where it loses all the tags, right? And so, how do you deal with that?
Yeah, that's exactly right. So DBT is a command line tool. So when somebody's using DBT with Airflow, they're using like a bash operator, and they invoke DBT and run all their models. And then they fit that in, so that might be one operator, and then all the other operators that depend on this data are separate operators inside of Airflow. So we've seen a couple different ways that people can use this. One is that we have some people that like break out their DBT DAG into an Airflow DAG. I think that one of the things that we're working really hard on is like how do we fit this better into other orchestration tools. So yeah, as used today, that's kind of how you would do it. We're sort of keeping an eye on better ways to do that.
Can I ask one more follow-up?
Sure.
When I haven't used DBT, but I looked at it, and one thing that I guess I'll just ask a question. It seems like, given that it's kind of like almost like a macro compiler for SQL, you get yourself in a spot where you have these like incredibly ornate or large SQL statements, you don't know what's happening. Yeah. And I started having like PTSD of when I was using C++ templates in the early 2000s, like if it's like insane error messages and stuff. I was wondering if you run into that, and how you deal with it, etc.
Yeah, it's definitely a consideration. One thing that we make sure to do in DBT is like every SQL template that we compile like renders out to a SQL script that you can then go back and read. And again, because some of these database technologies are so mature, it will tell you like, hey, you have an error on line 142 of your crazy SQL script, and then you can just go back and look at the compiled version of that that we wrote out to the file system. So that's helpful, but yeah, I agree. As these tools get more complex, that probably gets worse.